If your team uses Notion, let me show you how to turn your knowledge into an AI chatbot so you can find and interact with everything that you've ever written down. Use this as a basis for internal tools, customer support solutions, or as a portfolio project to land your dream job. The biggest problem with chatbots like ChatGPT is they don't have access to highly specific knowledge and non-public information like your personal notes, knowledge bases, or company help center. To fix this, a new technique was created, and in this video I will show you everything you need to know about it. And while almost all tutorials about this are in Python, I'm on a mission to teach the TypeScript community everything about AI. And if that sounds interesting to you, make sure to subscribe. So what is this mysterious technique? It's RAG, short form of Retrieval-Augmented Generation, which just means that before asking the AI, we have a retrieval step, where we fetch relevant information from a third-party source and pass it to the AI together with the question. But how do we get the relevant context? We use so-called semantic search, where we take our knowledge base, chunk them up in little pieces and turn these pieces into embeddings, which are the mathematical representation of meaning of words and sentences. Imagine a two-dimensional space where we got words of different meaning grouped together. Up here is the area with car-related words, and down there with flower and gardening-related words. So if we take this word, for example, engine, we could easily find other words with similar meaning close by. And this is how semantic search works, by creating an embedding and finding other embeddings close by with a similar meaning. Only that it's not in 2D, but in multi-dimensional space, usually thousands of dimensions. And that depends on the embedding model that you're using. And also we don't embed just one word, but one or multiple sentences. And these embeddings are stored in a so-called vector database, which gives us the ability to make a similarity search with a certain embedding to find other embeddings that are close by. To sum it up, first we create embeddings for our knowledge base and store them in the vector database. Then when we ask a question, we embed that question, do a similarity search inside our vector database, and give our initial question plus the result from the vector database. For example, if my knowledge base is about the Notion API and I would ask the question, how do I delete a specific page using the Notion API? I would first take that question, embed it, and then search for similar text chunks in our vector database. And it would get all parts from our knowledge base where it speaks about deleting pages using the API. Then it would take all of these chunks together with the question and pass it to the AI model, where the AI model just summarizes the results of the semantic search and gives us an answer. Now that you know the theory, let's start building our own RAG pipeline. To get started, I created this Notion database with one page with all facts about Ferrari, another one with data about Andrew Ng, and another one with facts about Germany. Then I created an API integration, copied the API key into the project and connected the API key here to that particular database. Then I initiated a new project. I installed the Notion client, LangChain OpenAI adapter, and Hono for the server. Also added the Open API key, the Notion API token, and the database ID into the env file. And the way to get the database URL or database ID is that inside the database you click copy link, and then inside the link the database URL is the last parameter of the real URL, so before the query parameters come. So when the program starts, we fetch all the blocks from the Notion database, and this is how it works. So first we create our Notion client using the token. Then we have a function to get all pages inside of a database, and here we use their collect paginated API helper function that just helps us to get all results from the paginated endpoints. And we run the database query function with the database ID. Then we filter the results so we only get the pages from the results. And then for each page, we query all the text blocks inside of that page. Then I got this function here, get text from block. I got that from their GitHub page, and it converts all the different types they have into text. Yeah, I just copy pasted it, so if you want to build on top of that, make sure that you read through everything and edit it to your needs. But yeah, we get all the blocks from the particular page and then put them into this block array. And this is of the type block result. I created that type and it's just the text and the URL. And then in the end, we return all of that blocks. And that is all that is needed to start interacting with the Notion database and getting all the text from all of the pages. After we've queried all the blocks, we have to save them into our vector database. And that happens here. So here I create the database and it's going to be a memory vector store. So it's just in memory for testing. But if you want to go to production, you can use Pinecone or Postgres with the PG vector or one of the other million options that there are. We also need an embeddings model. Here I use the OpenAI embeddings model, but there are a lot of models available. Yeah, they have like different performance capabilities. So do some research and do some testing, which one works best for your use case. And then also later to answer our requests, I get the GPT-4o mini model from OpenAI. So if we save the blocks, what we have to do is we have to convert these block results from our Notion query into documents. And a document is a class that comes from LangChain and is like an abstraction that is used to interact with our vector store. Each document consists of a page content, and this is the text that eventually gets embedded, and some metadata, and we can define that metadata how we want. And it's useful to add additional information to the document. And also it can be used later on to filter our results when we make the query. So you could imagine you put like a user ID or a company ID to make sure that you only search within data of this user or their company. Then we just add all these documents into our vector store. To query the vector store, I created this function and it calls the similarity search function on our vector store. We pass it in a query, then we can also pass it in the number of results. That's also called K usually. So how many results we want to get returned. And we could also add a filter function here to filter the documents that we want to search. After we retrieve the documents, I just turn them back into this block result type. And to run the full RAG pipeline, we first get our results from the similarity search, and then we just call the AI with this prompt. Yeah, I just freestyled something, but it seems to work. So the system prompt is that you're a helpful RAG AI, that you have to answer the questions using the context that we provide. We wanted to return the URL as well. And that is very crucial, is that we only wanted to respond with stuff from the context to make sure it doesn't hallucinate something that doesn't exist. And we instructed to say, I don't know, whenever it can't find the answer to the question inside the context. Yeah, and then we pass in here in the human message just the question and the context, and just return the string contents of this. And in the final program, we first fetch all the data from our Notion database, save it into the memory store, and then we use Hono to start the server. And the server just has two endpoints. It just returns a static HTML. And if we get a post request to the question endpoint, we retrieve the form data and then get the query parameter from the form data, run our RAG pipeline, and return the result. And this is the HTML. It really is the bare minimum to get the basic functionality working. We just have a form here, and then we use HTMX to make a post request to the endpoint and then put the result into this result div. So let me show you how it looks like. If we ask a question that is in our Notion, let's ask something about Ferrari. When we ask it what types of cars Ferrari currently produces, it responds with Ferrari currently produces several supercars, Grand Tourers, and one SUV. Let's ask another fact. What was the Gründerzeit? And it responds with the answer from our Notion page. And it also gives us the URL to the specific page. And if we ask something that isn't in our training data, we expect it to return, I don't know. So let's test that one as well. And it says, I don't know. So as you can see, we got the bare minimum running here, but there are a lot of things to improve. First, we should add in a real vector database, not the in-memory one. And we have to create some kind of strategy to always keep our vector store and our Notion database in sync. Also, we could use a stream API to get the answer streamed, so there's not such a long waiting time. When we run the reg pipeline, maybe we don't want the AI to put the URL into the answer, but instead we could get the URLs here from our blog results and then display them as a link in the front end. Yeah, these are just the biggest improvement I can think of right now. You can find the link to the project's GitHub in the comments, and make sure to ask any questions in the comments or if you have any other ideas or suggestions. Yeah, so that was it from my side. Hope you have a lot of fun building your own reg pipelines. Please make sure to give a like and subscribe to the channel. Yeah, thank you for watching and see you next time.